Welcome back, folks. All right, let's get moving in Chapter 2. Chapter 2 is, of course, sociological research methods. Um, when we talk about these methods, this is just the way that science and in general and sociology in particular uh, decide what information is worthy of moving on down the line and turning it into knowledge. So, all right, here we go. So, the major difference in methods, the way we think about methods in the social sciences, is the difference between quantitative research and qualitative research. Quantitative research translates the social world into numbers that can be studied mathematically. It's the foundation of statistics. And qualitative research uses non-numerical data like texts, interviews, photos, and recordings to help us understand social life. So it's important to note that within the social sciences, both of these types of research are valuable. Some researchers specialize in one type, some specialize in another type, but many use both methods in an effort to triangulate their data or to make sure that their findings are consistent no matter what kind of research they do. A good example of quantitative research is the U.S. Census, which uses surveys to analyze data from across the country. And a good example of qualitative research is Anne Frank's diary, which provides field notes based on her experiences and observations. So don't buy into the dichotomous understanding of methods. I'm either a quantitative researcher or I'm a qualitative researcher. You need to keep in mind that you can do both and you can do both effectively. But generally speaking, the reason that you don't do both is you're either comfortable with one method or another, or you just don't have the money to do both. The scientific method or the scientific approach is this is one of the most important impacting pieces of technology brought to bear on knowledge production in the entirety of humanity. Scientific method is a procedure for acquiring knowledge that emphasizes collecting data through observation and experiment. You might hear about the scientific method in your natural science classes like biology or chemistry. Same procedure. We're just doing it in the social world. Although natural scientists and social scientists study different things, ultimately both disciplines are scientific in that they collect and analyze data and understand the topic that interests them. The scientific method, this was the great equalizer. The reason that the scientific method was created was to be a pushback against how religious and monarchical institutions in the past were controlling the production of knowledge. And for example, in religious institutions, knowledge production only requires faith. And science says, no, that's not enough. Just because I have faith something exists doesn't mean it actually exists. And they decided that they wanted to rely on empiricism, using the five senses in order to define whether what you were seeing or what you were experiencing was actually what you were experiencing. Steps of the scientific method, of course, identify a problem or ask a question. Next step is conduct a literature review. You want to go out to the literature, see who's saying things that are in the realm of what you're looking at, so you can ground yourself in what has come before you. Science does not want to hear what you have to say until you've went to science to see what science has to say. Then you form hypotheses, create operational definitions for variables that then you can go out and research. You ultimately choose a research design or a method. Are you going to do qualitative? Or are you going to do quantitative? Or are you going to do a combination of both? Then you go out, collect the data, analyze the data. Then once you've analyzed the data, you're going to disseminate your findings. That's the end result of science, is to share what you found with the rest of the world. And then the rest of the world is going to chime in on your findings and give you some feedback. Next step, of course, the literature review. When embarking on a research project, it's important to determine what research has already been done. You don't want to spend hours and weeks or even months creating a wheel that has already been created. So you conduct a literature review. You go to the literature, you find out what folks have been saying about the topic that you're studying. You glean off some of the insights, the pitfalls that researchers might have encountered as they studied phenomenon that you're interested in studying yourself. Of course, you need to do a hypothesis. You formulate your hypothesis or come up with a scientific guess about what it is you expect to find. A hypothesis is not a question. A hypothesis is a statement about the world. There are more men than women in the world. That is a statement. It's not a question. Are there more women or are there more men than women in the world? It is a statement. There are more men than women in the world. And that's something that you can then go out, collect data on, and determine whether that's actually true or not. And then, of course, you want to create some variables. You determine what variables you want to study. For instance, if you want to look at test scores among fifth graders to see if eating breakfast improves performance, well, you have two variables: fifth graders taking a test and breakfast. So you can begin to see how you're going to break down this knowledge collection and knowledge interpretation process. You then want to operationalize the definitions. In order to operationalize your definitions, that just means you're going to make them useful. For example, what is breakfast? Is it bacon and eggs? Is it a piece of toast? A piece of candy? You have to come up with what it is in order to monitor what each kid is getting. You don't want a whole lot of difference within one meal to the next. You want that to be standardized because you want to be able to say each kid ate the same breakfast. Operational definitions allow you to be more specific in examining your findings. So operationalize your variables well, because in the end, it's going to make it easier for you. And then, of course, the last thing that we need to talk about is that research can ultimately lead to what Thomas Kuhn called a paradigm shift. And what a paradigm shift is a change in the way we think about some aspect of life, like an overall change. For instance, we used to believe that the world was flat, but new research gave us evidence that the world is actually not flat. That research in the end led us to a paradigm shift in our thinking about the world itself. So it took a long time for science. Science does not move easily and it does not move quickly, but it does move and it can change over time. So of course, that brings us to correlation and causation. These are important distinctions within the scientific knowledge production process. A correlation is a relationship between two variables. Causation is a relationship in which one variable causes another variable to change. And a spurious correlation is a relationship that seems to exist between two variables, but is actually caused by some external or intervening variable. The scientific method helps us determine and distinguish between correlation, causation, and spurious causation, because what we're seeing might not be what we're actually what's actually going on. So let's take an example. In Florida, there are a lot of palm trees and a lot of senior citizens. You want to examine the relationship between the variables. The variables in this case are palm trees and senior citizens. You see that in states with fewer palm trees, there are fewer senior citizens. And in Florida, where there are many palm trees, there are many senior citizens. Therefore, there is a relationship between the variables. Palm trees and senior citizens are correlated. Now, you want to ultimately see if there are any causations. Do palm trees cause senior citizens? Well, you can conduct an experiment in which where you plant 100,000 palm trees in Ohio and monitor the population. Suppose you see no change in the number of senior citizens. In that case, you can tell that palm trees aren't causing senior citizens. So what's going on? Well, there's a relationship between palm trees and senior citizens, but it's not causal. You start to investigate further and you realize that palm trees like warm weather and senior citizens like warm weather. There's a third variable, i.e. temperature, that you didn't think about in the beginning. This is a spurious correlation. There's a relationship between palm trees and senior citizens, but it's based on the fact that they both have a relationship to the third variable, i.e. temperature. Another example for this is the correlation between rape and ice cream consumption. As ice cream consumption goes up, the cases of rape go up. One might think to themselves, if they look at the data, that, wow, there's a relationship between rape and ice cream consumption, but the actual relationship is between temperature. As temperature goes up, ice cream consumption goes up, and as ice cream consumption goes up and temperature goes up, so too do the instances of rape.